when current flows through a cylinder, in that case, what's the magnetic field at a distance of r from the center of the cylinder? Here it's a circular cylinder. It means the cross section. This marker is a circular cylinder. You can just consider it. And if you take the cross section will be a circle. Now from the center at a distance r, say this point is your P. This point is your P. What's the magnetic field at the point P? For that ACL you can apply, that is Ampere's circuital law. So according to Ampere's circuital law, you have to consider a loop, closed loop passing through the point P. And say here this is a circular loop considered passing through the point P. Then as you know, integration of B dot dl, that is magnetic field vector and your length vector. And angle between these two is how much? 0 degree. So if angle between these two 0 degree, that means your what? A dot B equals to AB cos of 0, that is one. Directly you can say A vector dot B vector, that is scalar product of these two vectors will be your simply AB. That's why you can say directly it will be B into dl. That is magnitude of B vector is B, magnitude of dl vector is your D. Up to this clear. Rest of the part is simple mathematics. Now see, B is constant, means around this circular path everywhere magnetic field is constant. That's why constant will be out of the integral. And integration of dl, it's a closed integral actually. You should give this a closed integral. That means dl is a smaller part of this loop. Smaller part of this loop. Here is a smaller part. Integration of dl means total length. The total length is that is circumference of this circular loop, whatever loop we have considered. That's how much. That is your nothing but twice pi r. That's why it will be twice pi r. And this distance becomes radius. So from here get the value of B. Then B is equals to mu naught I by twice pi r. Twice pi r. This is the magnetic field, value of magnetic field at the point P. Direction, simply we can find out. Later on I am going to explain it. So magnetic field is your B, and you can, if you want, you can write the expression this way: mu naught by 4 pi into twice I by r. It is same thing. See, mu naught by twice pi, it was there. I have written mu naught by 4 pi. So in order to balance, you have to give twice I by r. So if you write this way, then mu naught by 4 pi, the value is 10 to the power negative 7. While you will be solving numerical problem, directly you can use the value, or you can replace this constant by 10 to the power negative 7. That's it. Now what? Okay. Now at the surface of the cylindrical conductor, suppose this is the cylindrical conductor, and at the surface. So if at the surface, then capital R is exactly equal to small r, then simply magnetic field B will be equal to mu naught by 4 pi into twice I by capital R. That is nothing but radius of the cylinder. Third case is there, say inside the cylinder, say somewhere here. Suppose now consider the point P here. In that case, inside the cylinder, then there are two cases. If current flows through the surface of the cylinder, say current flows not through the bulk of the cylinder, just through the surface of the cylinder, and you are coming inside the cylinder. That means here if you consider a closed loop, then you say inside this there is no current. Then mu naught I will be what? 0. In that case, magnetic field equals to 0. Remember, magnetic field inside the cylinder is 0, provided current flows through the surface of the cylinder. That's it. Another case is there, if current flows through the bulk of the cylinder. So that thing we are going to discuss now. Clear?